about determination of coastal setback, a managerial tool for coastal conservation. Outline. And coastal zones are always considered the context of enormous economic and social activities in the world. Population growth, the excessive exploitation of resources, coastal zones, pollution, the development of environmentally adverse activities, and the lack of coordination between activities on the shoreline are the main cause of pressure on these areas. In Iran, this research does not have a long history. As a problem, how to address the impact of the marine phenomena, especially the extent of sea floods on this management problem has been discussed. This is a research work to address this problem. The study area is here. The area under study includes about 10 kilometers of Persian Gulf coast in Hormozgan province. It is located in the west of shipbuilding complex and east of Loft Bridge Cape. The regional model designed in these studies embraces the whole area of the Persian Gulf and a part of the Oman Sea. Water level data in Chabar Tide Station in western Iran coast are used. The course of this modeling includes a whole year. It is showing that tidal fluctuations pattern in other year is similar to this model. A comparison of 2001 data and a 90-year course also approves this. The regional model this is area study. Boundary condition in the regional model, a Shahid Beheshti port, Chabar tide level. In the present research, the Persian Gulf and Oman Sea hydrographic data, as well as national cartographic center maps in Iranian coasts, are used to design this model. Among the synoptic stations of meteorological organization, Bandar Abbas and Qeshm stations are close to this area. Hence, they can be the representative of wind rows in the area under study. Bandar Abbas wind data and Qeshm wind data were used for modeling the production and diffusion of waves. This is maximum, minimum, and average water level in 2001 and all 90 years in the regional model. And table 2, frequency percentage water level in 2001 and all 90 years. Selecting computer model. Owning various capabilities to receive entrance data in wide area of applications and to present proper outputs for research and engineering usages, the mathematical model MIKE-21 is an appropriate tool for analyzing erosion phenomena in coast and determining sediment transfer rate. In this study, NSW, HD, and MT model of MIKE-21 are used. MIKE-21 HD is applicable in wide hydraulic range and its retrospective phenomena. This module includes the hydraulic modeling of the tide wind flows made by a wave, a storm flow, and flow wave. Regarding the modeling area, ISWM, ISWM results of Iran's sea wave modeling project. Data from 11 years and was used for the borderline conditions of the model to model tidal flows in the area under study, and using the above-mentioned model, geometry and depth data must be introduced to the model as a bathymetry file. Similarly, based on the modeling area and taking wind as the simulation basis, wind data from Resh Synoptic Station and Bandar Abbas Synoptic Station are used. The hydrodynamic model used in modeling tidal fluctuation MIC 21 HDFM is a strictly limited volume model. Bed-roughness coefficient and vortex viscosity coefficient are parameters applied in calibration trend as variable parameters. Accordingly, in this model, the bed-roughness coefficient will be the main parameter used to change speed and water level values and to obtain a minimum difference from the results of water level anticipation tables. In this project, it is considered 60 for the regional model. The model calibration is presented for Raja Ishar, Hormuz, and Kang ports based on a comparison of the modeling results of the regional model and the results of National Cartographic Center tidal anticipation. Results indicate that maximum wave height is about 0.9 meter, with dominant wave direction 245.5 degree in about 95% of the days. Wave height is less than 0.25 meter. As expected in this area, the climate of the waves is not so intensive in general. Hence, it seems that this climate has an insignificant effect on the water level increase in this zone. This is model calibration, Raja Ishar, Kang Port, and Hormuz. In this area, tide phenomenon is the main process affecting the water level. In these studies, it was tried to set fluid limit during modeling. We are embedding tidal line in the simulation area, that is to simulate drying process and wetting process by including fine elements in the cost. Another water level increase parameter is the storm surge resulted from the wind. In these studies, the quantities of this phenomenon were estimated for various return periods in waters approaching the coast. The relatively calm climate of wind in the area reduced the significance of a storm surge resulted from the wind, so that it was estimated about 0.3 meter with a 100-year return period. Waves break in coastal areas and its resulting water level increase is other issue under study in this research. Results showed that this parameter has no significant effect on water level increase and advance toward coastal areas, as the highest storm surge made by a 100-year wind in this area of the coast is estimated between 3 centimeter until 4 centimeter. This is fluid. It is fluid level at the highest fluid accord in the study area, and it is fluid level at the lowest ebb accord in the study area. And my output model in this here Excuse me.
It disappeared.
Yes, MPEG
It's finished. This is your slide.
model and film.
Which one?
This video output. Yes, output. My model in this year. Thank you so much. Any question?
Any question? Hydraulics, port engineering,
Hydrodynamics.
hydrodynamics, mainly hydrodynamics, right? That was one of the subjects I had to take in Norway. During the PhD period, hydrodynamics of the flowing objects used in oil business. It was completely, out of anywhere.
Hydrodynamic and used for coastal conservation.
Coastal conservation.
Yes.
Any question about sediment transport and waves, the other issues related to this presentation? No.
Thank you so much.
Thank you, Ryan. Thank you very much indeed.